Students, in this class we are going to learn about the angle of banking, or simply the banking of the roads. Before understanding this banking of the road, first we have to know why it is needed to bank the roads and what happens when a vehicle is moving along a circular path. Did it experience any kind of force? May it make it to tumble down? It happens. Generally what goes on when a vehicle is moving along a circular path? Here, let's see. Say it is a circular path, okay, has a radius of r. Okay, in this a vehicle is moving. Let's say it is the vehicle. Okay, here the vehicle is moving and it has to take a turn. Generally what could happen here? Whenever you think a vehicle is making a moving with a velocity of v, it is the direction of the velocity. And what happens? Weight of the vehicle will work vertically downwards, and as you know that normal reaction will work in this direction. Whenever a body is taking a turn, it experiences a force. We know that, let's say it is the radius. It is the direction of the centripetal force. A centripetal force is acting on the body, and you know that centripetal force is a center seeking force. Then there is a chance of turning down of the vehicle. Here what did happen here? Here, to avoid this, the tires of the vehicle and as well as the ground have to provide some friction. Here when it is taking the turn, here in this direction the frictional force will act. Okay, I am talking about, it's a circle, it is not banked one. Here when the vehicle is moving in this way, if you watch it carefully you will understand all these things. Weight is balanced by the normal reaction and it's a centripetal force. It has to be balanced with a particular force to avoid the turning down the vehicle. As you know that the centripetal force is equal to mv square by r, and it has to be balanced with, okay, the frictional force. And you have learnt frictional force is equal to mu n. Okay, it might be equal to mv square by r is equal to mu n. You watch the diagram carefully. N is equal to mg. Then you can write n is equal to mg, and we get mv square by r is equal to mu mg, where mm get cancelled and v square is equal to mu rg. Okay students, that is v is equal to under root of mu rg. It is the safest velocity of the vehicle to move along the circular path. To move along the circular path. If the vehicle is moving with velocity, this velocity, okay, then it will move. Lot depends upon the friction between the road and as well as the tires and as well as the radius of the circular path. Here generally we watch when we are traveling, we see some signboards. Maximum speed limit is 40 km/h. When you are negotiating a car, there is a road which is in carved path. Sometimes what happens? Okay, if you go with the velocity which is more than this, that means minimum velocity you give, there is a chance of accident, and fatal accidents happens in that way only. Okay, here if you know the velocity, then you can estimate the radius of the circular path also. Okay students, it is the normal. That means what? We are negotiating a carved path, but if the road is banked, then what could be the velocity? And what parameters involved in to avoid the turning down of the vehicle we will learn. Okay students, now we are going to talk about banking of the roads. First of all, you have to understand what is meant by banking. What is meant by banking? Banking is nothing but elevating one side of the road with the horizontal. Elevating one side of the road with the horizontal is known as banking. The angle made by the elevated road with the horizontal is angle of banking. Let's see. Okay students, let's say it is the elevated path. That means it is the ground and we elevated this one to an extent of height, and it's making an angle of theta with the horizontal. We call it as the angle of banking. Let's say a vehicle is moving. Okay, it is the vehicle and these are the tires of the vehicle. I am showing the back part of the vehicle. Okay students, the vehicle is moving in this way. The vehicle is moving into the plane. It is the back part of the vehicle. If we keep that vehicle in that way, we know that the weight of the vehicle always works vertically downwards. It is the weight of the vehicle which is working vertically downwards. Obviously, you know that it is the normal reaction. Okay students, normal reaction is always perpendicular to the surface. And we have to see what forces it is experiencing. Right now we learn that when it is negotiating a curve, it experiences a centripetal force. Let's say it is the centripetal force and it has the magnitude of r. Actually it is moving in this way, in a circular path. Okay students, now we are resolving this centripetal force into components. Okay, one such component is this. Okay students, and it is one more. Okay students, let's take it as the theta. Then obviously it is mva square by r cos theta. Okay, getting me? And this might be equal to mv square by r into sine theta. Okay, then what about this? It's the weight of the vehicle. Now we are resolving the weight into components. See, weight has been resolved. Okay, say it is theta and it will equal to mg cos theta and it is mg sine theta. Okay students, here I hope you understood. I am drawing in a larger way. See this. Okay, let's say it is the vehicle and the weight of the vehicle is acting vertically downwards and it is the angle of banking. I am resolving the weight into components. It is, okay, I resolute. It is equal to mg sine theta, since it is the theta, and it is equal to mg cos theta, I hope. Okay, students, while negotiating car, it experiences a force. I said it is the centripetal force. It is the centripetal force. It is mv square by r. Okay, I'm resolving this centripetal force into two components. Here it is the theta. It is mv square by r cos theta. Same what I did there, and one more component in this direction. It is mv square by r sin theta. These two get balances by the normal reaction. It's the needed diagram, students. I hope you understood. Here if you watch it carefully, here mv square by r cos theta might be equal to mg sin theta. Okay, if the two are equal, then we should not worry. That means the vehicle get balanced. Okay, just imagine that here mg sin theta is greater than mv square by r cos theta. Or another example you can take. Okay, what's that? mv square by r cos theta is greater than mg sin theta. Then here the difference between these two, either it is mv square by r cos theta is greater than mg sin theta, or mg sin theta is greater than mv square by r cos theta. We get a net force. That net force is provided as the frictional force acting between the wheels and as well as the road. Okay, the net force. The difference of these two forces provides a net force. This net force, okay, provides the frictional force between the road and as well as the tires of the vehicle. Okay, let's take such kind of one instance. I told you here, if, see this, I am giving the condition, if mg sin theta is equal to mv square by r cos theta, then the vehicle moves safely, I said. Okay, we will write a equation by taking these values. Get cancelled. You get sin theta by cos theta is equal to v square by rg. Okay, students, or v square by rg is equal to tan theta, and you know that mu is equal to tan theta. Okay, students, that is v square is equal to mu rg, or v is equal to under root of mu rg. Okay, it is the safest velocity. In the same way, you can find out the angle of banking. What is the angle of banking required? Tan theta is equal to v square by rg, and theta is equal to tan inverse v square by rg. Okay, it is the minimum angle required to avoid the overturn of the vehicle, and it is the minimum velocity. I hope you understood. Then after, we are taking the cases. Okay, are you following, students? Okay, now we are taking case 1. If mv square by r cos theta is greater than mg sin theta. Okay, students, the difference between the two will provide the safety of the vehicle. The difference, these two are the forces. The difference between the two might be one more force we can write it as mv square by r cos theta minus mg sin theta is a net force. Okay, this net force provides the friction. I'm writing it as the friction. Okay, if mv square by r cos theta is greater than mg sin theta, what happens? There is a chance of topple down of the vehicle in this direction. Then a frictional force will develop in this direction, which prevents the turning down of the vehicle. Okay, students, see this, you can write mv square by r cos theta minus mg sin theta is equal to frictional force. As you know that frictional force is equal to mu n. Okay, I'm substituting the value here. It is equal to mu n. Or you can write mv square by r cos theta is equal to mu n plus mg sin theta. But here, if you watch it, normal reaction n is equal to mg cos theta plus mv square by r sin theta. See this, n is equal to mg cos theta, okay, plus mv square by r sin theta. It can be written as mu of plus mg cos theta plus mg sin theta, and also it can be written as mv square by r cos theta is equal to mu okay plus mu mg cos theta plus mg sin theta. Okay, students, I am bringing mv square by r terms at this side. Then what do I get? mv square by r, okay, into cos theta minus mu of mv square by r sin theta is equal to mg, I'm taking as the common, of mu cos theta plus sin theta. Okay, students, here mv square by r of cos theta minus mu sin theta is equal to mg of mu cos theta plus sin theta. Get cancelled. V square, okay, is equal to gr of mu cos theta plus sin theta upon cos theta minus mu sin theta. Okay, students, from this we can write, okay, V is equal to under root of gr into mu cos theta plus sin theta by cos theta minus mu sin theta. It is the desired relation. Okay, it is the minimum velocity required by the vehicle to avoid the turning down. Okay, students, let's hope you understood. What is the case 1? That means what? Here we learn that if mv square by r cos theta is greater than mg sine theta. You have to remember this one. In this case, the vehicle will turn down. There is a chance of turning down in that direction. Then immediately a force, that is difference between the two, acts like the frictional force. Okay, it provides the safety to the vehicle. Okay, and we got a condition for the velocity. V is equal to under root of gr. Okay students, finally we had this equation. Okay students, let's take one more case. In previous case, we learned that how can the velocity can be calculated by resoluting the weight and as well as the centripetal force into rectangular components. And we learned that when mv square by r cos theta is equal to greater than mg sine theta, the frictional force will work towards the center of the curved path. And now say we are going with one more case. Here case 2 is the case 2. Okay, in this, here mg sine theta is greater than mv square by r into cos theta. Is the next case. Okay students, we are taking mg sine theta is greater than mv square by r cos theta. Obviously, what you learned before, the difference between the two provides the force. Say it is mg sine theta minus mv square by r into cos theta is the net force. It is equal to frictional force. In this case, the frictional force acts in this direction. Okay, as you know that frictional force is equal to mu n, and it can be written as mu of n normal reaction is equal to mg cos theta plus mv square by r into sine theta. Okay students, further it can be written as mg sine theta, okay, minus mv square by r cos theta is equal to mu mg cos theta plus mu into mv square by r into sine theta. Okay students, we are writing the similar terms at one side. Mg sine theta minus mu mg cos theta is equal to mu of mv square by r sine theta plus mv square by r cos theta. Here all the m's get cancels, and what we get? G of sine theta minus mu cos theta is equal to, okay, I am bringing the r here, it is rg, v square of sine theta, I mean mu sine theta plus cos theta. Okay students, then v square can be written as gr of sine theta minus mu cos theta by mu sine theta plus cos theta. Okay, it yields velocity, minimum velocity of the vehicle. V is equal to under root of gr of sin theta minus mu cos theta by mu sin theta plus cos theta. It is the velocity. It's the velocity. See, in this one, the frictional force will act in this direction. Okay, let's say we are taking a case more. If frictional force between the tires is equal to 0, then what to get? V is equal to under root of sin theta minus 0 into cos theta by 0 into sin theta. Okay, plus cos theta. Okay, students, and we get V is equal to gr into tan theta. Okay, students, where theta is the angle of banking. Theta is equal to angle of banking. Or simply, you can write V square by gr is equal to tan theta. Okay, and tan theta is equal to V square by rg, where theta is known as angle of banking. Students, I hope you understood this topic very well. It is very useful for solving the problems to find the safest velocity of the vehicle, and as well as to what extent we have to bank the roads. I hope you have followed the class. If you like the video, subscribe my channel. Thank you for watching the video.